Guys, welcome back to TechDose, and in this video we will look at the minimum cost to make at least one valid path in a grid problem, which is from Leetcode number 1368. And a prerequisite before watching this is to watch my video on the Dijkstra algorithm. You can also consider solving find the minimum time to reach last room 1 and 2 problem, which is from Leetcode number 3341 and 3342. So I have already made all these videos in detail, and all the relevant links will be in the description below. If you are new to Dijkstra, then consider watching all these videos before proceeding with this current one. But if you know Dijkstra, then let's proceed. In this particular problem, given an m by n grid, each cell of the grid has a sign pointing to the next cell you should visit if you are currently in this cell. The sign of the grid at ij can be 1, which means go to the cell to the right. 2 means go to the cell to the left, 3 means go to the lower cell, and 4 means go to the upper cell. Notice that there could be some signs on the cells of the grid that point outside of the grid. You will initially start at the upper left cell, which is 0, 0, and a valid path in the grid is a path that starts from the upper left cell 0, 0 and ends at the bottom right cell, which is m-1, n-1, following the signs of the grid. The valid path does not have to be the shortest. You can modify the sign on a cell with cost equals to 1, and you can modify the sign of the cell one time only. Return the minimum cost to make the grid have at least one valid path. Now in this case, when it mentions that the sign can only change one time, well, you will not require to change the sign more than one time, because in one time you can change it to the most optimal direction, the direction that you want to travel, right? Now in this particular problem, since I want to start from the top left corner as mentioned 0, 0, so the 0th row and the 0th column, and you know that the destination node or the final cell there where I want to reach is the row number m-1 and the column number n-1, right? So it has clearly defined what is the source and destination. And in this particular case, if you move in the direction of the given arrow, then you don't incur any cost. But if you decide at some point that okay, I need to move down and the arrow is given in some other direction, then we have to add cost plus 1 to it. Okay. So if you do follow this technique, then it is asking about can you reach from the top left corner to the bottom right corner? Well, this is a reachability question, but if we have a path from the top left to the bottom right, then definitely we will be able to reach. If there is no path, then we will not be able to reach. In this particular problem, we will always be able to reach from source to destination, but the problem is asking about minimizing the cost that we incur in this movement. So the minimum cost to reach from source to destination is the exact same problem as the Dijkstra's single source shortest path. The meaning of shortest path and minimum cost, you can consider it to be same. And also the maximum cost and the maximum cost path is the same, right? So having seen this, let's look at the constraint. Now in this case, you are given the m by n to be 100 by 100. So the maximum matrix cells will be 10 to the power of 4. So definitely if you write an mn square algorithm, then that is not going to work, because this will be 10 to the power of 8. So we need something better than the mn square algorithm, and we already know that the Dijkstra will be e log v. That means in this case it will be number of cells log of mn. Well, if you didn't understand this, you will get it at the end. In the grid values, you will get the direction from 1 to 4 mentioned as right, left, down and up, right? 1, 2, 3 and 4. So let's now look at an example for better understanding. In this case, we are given the direction matrix, and all the directions are given. For moving right, you will get a number 1. For moving left, your matrix will have number 2, and accordingly 3 for down and 4 for up. So we need to reach from our given source to the given destination node. So let's see in what possible ways can we do this. Well, if I happen to choose a path from the 0, 0 and I try to move to the right hand side, then you see that the direction of the arrow is just in some other direction, right? It is in the opposite direction. So the cost will be added and the cost will be 1 here. Now again, if I move to the right, the cost will become 2. If I move down, the cost will become 3, because I am always moving in the direction which is not according to the given matrix. So if I move down, then the cost will become 4. So in 4 cost, actually I am reaching to the last cell. 1, 2, 3 and 4, right? So yes, I can reach from the source to the destination in 4 cost, but the question is about, can you minimize this cost? Well, let's see another way to do it. So if you try to go down here, then the cost plus 1 will be incurred. Okay, so I will be adding cost 1. But if you move to the right here, then the cost 0 will be added because you are moving in the same direction as the arrow is given. Again, if you try to move down here, then the cost 0 will be added because we are moving in the mentioned direction. And from here, if you move right, which is not according to the mentioned direction for going up, then we will be adding plus 1 cost here, and we are reaching to the last cell. So the total cost incurred by this path is only 2, while for the previous path it was 4. So if you try out all the possibilities here, then you will find that 2 is the minimum cost for this particular assignment, and therefore the answer in this case will be 2. So the input is not given in the form of an array, but it will be in the form of integers as mentioned according to the direction. The numbers will show you the direction, right? So our goal here is, given an m by n grid, we need to find the minimum cost path from the source to destination, and moving in the mentioned direction will incur 0 cost, but if you move in any other direction, then cost 1 will be added as a new cost, right? Now in order to move in all the 4 directions, we need to make 4 directional calls, and if you are new to it, then I will just repeat it up. In this case, if you are at an xy coordinate and if you want to move up, right, down, left in all the 4 direction, then you can consider making the 2 arrays dx dy, which will help you make these moves. In this particular problem, the numbers assigned in all the 4 directions are 1 for the right, 2 for the left, 3 for down, and 4 for up. So I will be making it according to how the question has been numbering all these directions. So this index number 0 will try to make the right call, index number 1 will try to make the left call, index number 2 will try to make down call, and 3 will try to make up call in the exact same order as right, left, down, up. Let's say that in your first call you want to move to the right hand side. So from x comma y you go to x comma y plus 1. So your column is changing but row is not changing. So you have to add 0 to the x coordinate and 1 to the y coordinate, as I have mentioned here. So similarly you can see that I have added 0 to the x coordinate and 1 to the y coordinate. If you want to move to the left hand side, again your x is not changing but your y is changing by -1. So you need to add 0 to the x coordinate and -1 to the y coordinate, and you can just figure it out like how it is written, right? Now according to the problem statement, if the I plus 1 value will be equals to the direction, then the new cost incurred will be equals to the old cost, because we will not be adding any cost. The cost added will be 0. Otherwise the cost added will be 1 for the current move, and that is the reason why I have made this dx dy in this particular case, because the comparison of I plus 1 with the direction is easy. Because here if you look at index 0, this is saying a right move, and 1 in the matrix was already giving you the right move, right? The 1 was giving you the right move. So the comparison is easy with I plus 1. Otherwise you have to do explicit comparison, right? So that can be a little bit hectic for you. Now let's see a dry run of this entire problem using the single source shortest path, which is the Dijkstra algorithm. It uses the BFS plus heap approach, and you should always remember that Dijkstra is a greedy approach. So in this particular case, I will be starting from the 0, 0, which is the source node, and my destination node is 2, 2 for the given problem. That means the bottom right corner. I have already drawn the arrows structure so that it is easy for you to follow, that being at a cell which direction I am expected to move. Now according to the last slide, which I had already explained, I will be making the right, left, down, up calls in this particular order, and I will always be updating the new x and new y using the current cell x comma y. Now since I want to find the minimum cost path from the source to destination, it is equivalent to finding the shortest path, and at any point of time we have to maintain the cost, right? So for maintaining the cost, I will be taking the heap node with the cost comma x comma y. The x comma y coordinate will be telling where I am currently present in this entire matrix, and the cost will keep the entire heap sorted based on the cost. Because since this Dijkstra algorithm is a greedy algorithm, so I will always want the next best option to be available to me. So if the sorting of the heap happens according to the cost and according to the min heap, then only I will be getting the next best option, and that is the reason I will be taking a min heap here. But if the question was about maximum cost path or maximizing the cost or maximizing the profit, then I will be going with a max heap. So that will become the longest path from source to destination, and that is the same as the shortest path, right? So having known all this, I will start my processing. But before processing, I don't want to visit the same nodes again and again. So I will be taking a visited array and I will be marking all the nodes as false. So all the nodes will be initialized to false in this visited array of size m by n. Okay, I have initialized all of them as false. The min heap will have the source node initially. So since we are starting at 0, 0, the cost at 0, 0 will be 0, and the index, that means the row comma column, will be 0, 0. Now I will be starting to process unless the heap is empty, or otherwise I have reached to the destination. So in every step I will be taking out the top of the heap, which is 0, 0, 0. So I am at this location. From this location I will be making all the 4 directional call: right, left, down and up. But before making any calls, I have to check if this current node is already processed. Then you will check that it is false, it is not already processed. So I will mark it as true, that yes, it is now processed. And now I will try to make all the 4 calls. So if you try to make the right call, you have to check if it is out of bound. So first there should be a bound check, and the second thing will be, you will be checking it for the visited array, because if it is already processed or not. So it is not processed. So what I can do is I can push this, and are we moving in the direction mentioned? So you see that the direction mentioned is 2, which is to the left, but I am moving to the right. So the cost, the previous cost was 0. Therefore since I am moving in a direction where it is not mentioned, so I will be adding cost 1 to it. So the cost will become 1, and the new cell to which I am moving is 0, 1. So this will be pushed into the min heap, right? Now after right I have to make the left call. So this will be out of bound, I cannot make it. The down call. So check this 1, 0. This is also not processed yet. So what I will do is, since I am moving in some direction which is not mentioned, the mentioned direction was to the left. So I am trying to move down. So the cost 1 will be added to the current cost. So 1 will be 0 plus 1, and we are going to 1, 0. So this will be pushed into the heap, right? Now we need to make the up call, and you see that it will be out of bound, so I cannot make it. So we are done. Now since this is a min heap, it will be arranging based on cost. But if two costs are same, the second parameter will be the one by which it will be arranging. So it is using ascending order. So 1, 0, 1 will be the one chosen. So we will be at 0, 1. Now from this I will be making right, left, down, up calls. Now we need to check if it is already processed. It is not processed, so I will mark it as processed. Now I will be trying all the 4 directional calls. So let's try the right call. So the right hand side is not visited and it is also within the bounds. So the next thing is what will be the cost. So since we are moving in a direction which is against the mentioned direction, not according to the mentioned direction, so I'll be adding plus 1 cost to the current cost, and this cost will become 2. We are moving to coordinate 0, 2, so that will be added. Now we will be trying the left call, but this is already processed. Now we will be trying the down call, and in this case it is also not according to the direction mentioned, so the cost 2 will be added with 1, 1, because this is also not visited, right, as you can see. Now we will try the up call, but this is out of bound and we are done. Now from the available option, 1, 1, 0 is taken out because this is the best option. It is having the minimum cost. So if it is taken out, the 1, 0 is the coordinate, and you can see it is false, so mark it as true. Okay, because now it is getting processed. So once we have done this, we are at 1, 0. We will try all the 4 directional calls. So when I try the right call, so is it processed and is it within the bound? Yes, it is within the bound. So is it processed or not? So 1, 1 is false. It is not processed. So that means I can add this. So is it according to the direction what is mentioned? Yes, it is according to direction. So the current cost will actually be the new cost. So the cost will remain to be 1, and we are reaching to 1, 1 coordinate. So 1, 1 will be pushed. Now we will be trying the left call, and the left call is out of bound. We will try the down call. This is within the bound and this is also not processed. So what I will do is, since it is against the direction mentioned here, so I'll be adding plus 1 cost to the current cost of 1. So that makes it 2, and we are moving to 2, 0. Now I will try the up call, and this is already processed, so I don't need to do anything for that, and we are done with this. Now in the entire min heap, the next best option chosen will be 1 comma 1 comma 1, because it is having the minimum cost. So when we take out, we will be checking it is not visited, and we will be trying all the 4 directional calls. So first call will be to the right, and is it according to the mentioned direction? No. So what will be the incurred cost? The current cost plus 1, so 2 comma 1 comma 2. Okay, it will be added. Now try the left call. Now the left hand side cell is already processed. Try the down call. Now the down call is according to the mentioned direction, so no extra cost will be incurred, and you will be having cost 1, and the cell number 2 comma 1 is reached. Okay, this 2 comma 1 is reached with the same cost. Now we will be trying the up call, but this is already processed, so no need. Oh, we are done. Now while processing only, I should have made this as true. That means it is visited, and then I should start processing, but you can do this at the end too. Now when we are done, I will be taking the next best option, which is 1 comma 2 comma 1, because 1 is the minimum cost. So I will be going to this 2 comma 1, and I will be trying all the 4 directional calls. So since it is not visited, I will mark it as visited and make a call to the right hand side. So in this case, is it according to the mentioned direction? No. So the cost will be the current cost 1 plus 1, so 2, and the cell number where we are moving is 2 comma 2. So we are done. Left call. So is this 2 comma 0 already processed? No, it is not processed. So I can move there, and this is against the direction. So the cost will be current cost 1 plus 1, and 2 comma 0 is the cell where we are moving. Okay. Now we will try to move down. This is out of bound. Try to move up, and this is already processed. So we are done. Now what will be the next best option? So see that all the costs are 2, 2, 2, 2, 2, 2, 2. So if you look at the second values, this is 0, and this is 1, 2, 1, 2, 2. So 0 is the minimum value, and that is why 2 comma 0 comma 2 will be taken out as the next best option. So the coordinate is 0 comma 2, and the current cost is 2. Now from here I will try 4 directional calls. So since it is not processed, I will try to process it. So I cannot make a right hand side call, it is out of bound. I cannot make a left hand side call because this is already processed. I can make a down call, yes, because this is not processed. And by the way, while I am processing something, I should have marked this as true. So since it is not processed, I will be adding it and you will have to check the direction. It is to the left, but we are trying to make a down call. So I will be adding cost 1 to it. So the current cost was 2. I will add cost 1. So 3 comma 1 comma 2. This will be pushed into the heap. And I cannot make an up call because this is out of bound, and we are done. After this, you look at the next best option. So we have 2 comma 1 comma 1 because 2 is common everywhere and 1 is the minimum value out of the lot. So 2 comma 1 comma 1 is the best because this 2 comma 1 comma 1 will be compared with this 2 comma 1 comma 2. So the third value 1 is smaller here. So this will be taken out. We are currently at this 1 comma 1. But if you check it out, it is already processed because it is marked as true. So I will not do anything. Again, the next best option will be 2 comma 1 comma 2. Okay. So in this case as well, it is already processed, the 1 comma 2 coordinates. So I will not do anything. Now out of the leftover option 220, 222, 220, you will see that 220 is the next best option. So I will be taking it out. So the coordinate is 2 comma 0. Now this is not processed. I will be marking it as true. But from this node, you cannot make any call. On the right side, it is visited. Left side is out of bound. Down is out of bound. Up side is also visited. So you cannot do anything. Next best option 220 is the same and you cannot do anything because it is already processed. Right. Now out of the leftover options, the best option is the cost 2. It will be taken out. And when it is taken out, you see that the XY coordinate is 2 comma 2, which is the destination. And as soon as you see that it is equals to destination, whatever is the cost must be your minimum cost, because the first time whenever you reach to the destination using the greedy approach from the source node, then that must always be the minimum cost, and therefore we will return 2 as our answer in this case, and that will be the minimum cost path to reach from the source to destination. So I hope you are able to understand this entire approach. In this particular case, the number of cells are m into n, therefore the space complexity will be mn due to the visited array, and we have also taken the min heap, by the way. So that is also adding up to the space complexity, and the time complexity will be there can be mn number of cells into the heap, and the heap is keeping everything sorted. So that is a logarithmic order, and therefore the time complexity will be order of mn log of mn, and the space complexity is order of mn. So let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code, I have defined the pair integer using the name PIP. And I have defined the bound check using is valid, where I will be providing XY coordinate with the entire size of the matrix m comma n, and this will return true if the coordinate is valid, otherwise it will return false. Now having seen that, let's look at the main driver function. In this case, we are given the min cost function and the entire grid. So I'll be finding the number of rows and columns, and I will be defining the visited array initialized to the initial value of false by default. So in this case, I will be defining a min heap, and as you know, we will be having 3 values. The first value is the cost, and then you have the x and y coordinates. So that is what is mentioned in these 3 integers. Now I will be pushing the start node into the heap. So always we have to start at the top left corner. So the xy coordinate is 0, 0, and the cost to reach to the starting cell is always 0. So that is why I am pushing 0, 0, 0. And you already know this dx dy, it is to make the right, left, down, up calls in this particular exact order. And then now I will be processing this entire Dijkstra algorithm using the heap. So until the heap is empty, I will process this. So first I will be taking out the best option from the top of the heap, and I will be removing it from the heap. So I will be finding the cost xy coordinate, and I will be checking if this is already visited. I will not process it again. I will just continue. Now if you are reaching to the destination for the first time, then the cost which we incurred must be the minimum cost, because we are applying a greedy algorithm, and that is why we need to return the cost as the min cost. Otherwise, if we have not reached to the destination, I will mark the current cell to be visited, so it will be marked as true, and I will try to make all the 4 directional calls in the right, left, down, up in this particular order. So if the new x and new y is within the bounds and also it is not visited, then I will be calculating the new cost. So if it is according to the direction which is mentioned in the matrix, then I will be adding 0 cost for it. But if I have any of the other 3 directions, then I will be adding cost 1 for it, and I will be pushing the new cost comma the new index new x new y into the min heap, and this is what we will be repeating. So at the end we will be getting the minimum cost as our final answer, and I hope this code is clear to you. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of this programming videos. See you guys in the next video. Thank you.